All right, so let's take a look at this section. So in 3.1, we talked about logical statements. Okay, and really our focus there was just, is this a logical statement or not? And then we did talk a little bit about if we have a logical statement, how we negate that, how we get it the opposite. And so in section 3.2, what we're going to do is we actually are going to be a little concerned here with about whether a statement is true or false and how that plays out, especially when we combine different statements together. Okay, what kind of effect does that have on the truth value? And to do that, it can get complicated trying to wrap your mind around exactly what's happening logically if you have more than just one or two little simple statements. Okay, it gets can get confusing. Okay, so to avoid that, one way we keep track of all this is by using these things called truth tables. Okay. So our goal in this section is going to be, it says construct truth tables. We're just filling out part of the table. And we're just filling out part of the table. So not quite having to do it from scratch in here. Okay, so let's get our definition here. When we talk about a truth table, it's a table. Okay, that part's pretty clear. And the idea is that we're going to have a row in our table for each possible combination of logic values we could have. So maybe if we think about, we have a logical statement with two simple statements and they're joined together, then we'll have a row for each possible true-false combination. Okay. And in order for us to be able to keep track of what's happening with the logic, we kind of have to look at the truth table for each way we join logical statements together. Okay, so each type of conjunction or each type of connecting word, I should say, that we can use to make logical statements. So remember, last time we had three, and we had and. We could use and to put logical statements together. We had or, and then we had the one that's kind of a troublemaker, implies or if then. Several ways that one can be worded. Okay, so those are our basic building blocks, okay, along with negation that we've talked about. Okay. And we're going to look at how to deal with more complicated things here. Okay. So our first connecting word that we used to put two statements together was and. Okay. So if you take two statements and join them with and, we get what we call a conjunction. Okay. I know in English we normally call and a conjunction and or a conjunction and several other words. But in logic, we only call it using and a conjunction. Okay. And the idea about what happens with our truth value when we have a logical statement is that in order for the whole statement to be true, both of the smaller statements have to be true. Okay. Or here, the way it's worded, it says a conjunction is true only when both statements are true. Okay. Otherwise, it's false. Okay. So and is kind of like saying both of these have to be true. Okay. So when we're saying and. And the way this would look in a truth table, it would be something like this. So this part over here, the first two columns, don't stress if that looks complicated. All that is that's just listing out the possible combinations of the truth value. So we've got our two simple statements A and D, so we could have true, 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 false, false, true, false, false. And so that's no big deal. That's just listing out the possible combinations. And what we want to focus on here is this last column. So this tells us if we're using and, remember that's our symbol for and. If we're using and to join two statements, the only time our conjunction, our compound statement is going to be true is if both of the smaller statements are true. Okay? I got to have first true and second true. Any other combination will end up with a false compound statement. And we can kind of reason that out if you think about it. Because when we say and, we're saying things like, I have two hands and I'm wearing a shirt. Okay, so we're saying both of those things are true. So the only way that whole statement is true is if both pieces are true. Okay. Got that one? Think you got and? Okay. The next one we need to talk about is or. If we join two statements with or, our compound statement gets called a disjunction. And the way I think about it in my head is I think about if either smaller statement is true, then the compound statement is true. The way our definition slide gives it to us, it says a disjunction is always true unless both statements are false. Okay. And then here's our truth table. Again, the first two columns, they're just like the first two columns on the last one. Yeah, they're just combinations of the different combinations of true and false. So the part we want to focus on is this last column. It says if we're using or, then our compound statement's going to be true unless there's only one situation where it's false, and that situation is when both of our simpler statements are false. The way I think about it in my head is with an or statement, if either simple statement is true, the whole thing's true. And so here, they're both true, so it's true. Here, the first one's true, so it's true. Third row, the second one's true, so it's true. And the only way it can be false is if everything is false. The tricky part of wrapping your head around this is just keeping the two separate and remembering which one's which. Okay? So if you can come up with some way for that to stick, then you're in really good shape. Any questions on that one? No? No? And then we've got one more. Here. The troublemaker. And that's when we use an implication, when we say if then. And that's what we call a conditional statement. So with if thens, we're saying if this first thing, then the second thing is going to happen. So we say if the condition, then the result. We call them conditional. And our rule here is the hardest one for me to remember. I don't know how it'll be for everybody. But the short version is there's only one time when a conditional statement is false. And that's when the first part is true and the second part is false. Then the whole thing will be false. Any other time, a conditional statement is going to be true. Okay. That one's a little harder to wrap your head around. So we're gonna fill out a truth table here. We'll talk about each little case as we go. Okay. So let's look at a couple of statements here. Bless you. We want to think about this compound statement that says, if it rains, then we will stay home tonight. Okay. So we're going to call the first part that it rains, W, and then we'll call the second part, we'll stay home tonight, Z. So in symbolic form, we're saying, if it rains, then we'll stay home tonight. We want to make the truth table for that. So again, the first two columns will have a column for W and a column for Z. And they're just the different combinations of true and false, so nothing really to worry about there. On the last column is where we have to think about the rule, right? Have to think about the logical rules here. So we want if W then Z. I got to put a bar through my Z. I tried to find it, but just my habit. So our rule, if I'm filling this table out, I think about our rule, and our rule for conditionals say the only time a conditional statement is false is if the first part is true and the second part is false. And so on our table, that only happens one time. That only happens on that row, right? Where the first part is true and the second part is false. That means this thing is going to be false. So on that row, I'll put an F for false. And the other ones we don't even have to think about, okay? Because they're going to be true. Okay? But let's kind of see if we can think our way through that and see why that is. Okay? I'm going to help you remember. So let's think about the case where both statements are true. So our first part was if it rains, so we're saying it does rain, and we do stay home tonight. That means our statement was true. Right? We did what we said we were going to do. Okay? Where we get the false, okay? So on the first part, if it rains, so we'll say it does rain, but then it says the second part's false, so that would be we didn't stay home. Okay? So then that's like we've broke our word, right? We've broken our promise. Okay? So that meant that the thing we said, the compound statement, was false. The last two are the ones that make it confusing. Okay? The idea here, though, is that if you're making some type of conditional statement and the condition you come up with is false, you can say whatever you want to after that. Okay? Because if you're basing it on a false condition, you're going to end up with a true statement. Okay? So I could say, if I'm 10 feet tall, everybody in here gets an A. And that's a true statement. I'm telling the truth. Okay? But it's only because I'm not 10 feet tall. Okay? So that's a weird situation. There's actually a name for these two. We say that in this case, these logical statements are vacuously true. You don't have to know that. Okay? We say they're vacuously true. Okay? It doesn't have a lot of meaning, but it is technically true. Okay? So it's a weird situation there. In the context of this example, we would say it doesn't rain, okay, but we do stay home tonight. Okay? So that would be okay. Right? We didn't say what we were going to do if it doesn't rain. So that's true. And then on the last one, we would say it doesn't rain and we don't stay home tonight. That's okay. Also, that's still a true statement there because we didn't say, again, what was going to happen if it doesn't rain. We were only saying if it rains, what we'll do. So it's a little weird. There. That's our rule with if-thens. Questions on that one? Did it make a little bit of sense? At least you got the rule. You got the rule and stuff. Good deal. Okay, so let's use these to make some truth tables, okay? Or fill out some truth tables. Okay, let's look at this compound statement. Okay. This one we want to fill in the truth table for A, and then what's that next symbol? Or, yeah. And's the one that looks like an A, yeah, without the bar. So or is the one that goes the other way. So A or not B. Yeah, good. Squiggles are negation. Yeah. So if we're going to fill out a truth table here, we need a column for statement A, a column for statement B. We'll have those with their different combinations of true, false. And on this one, we've got an extra column we have to make because we're not worried about, in our final statement, we're not worried about what's going on with B. We're worried about what's going on with not B. So we'll make a column for not B. And doing a truth table for a negation is really easy. The only part I'm looking at when I'm doing this not B column is the B column. Okay, so I'm just looking at this column. And then I want to fill in the not B column. So if these are the truth values for B, how do we figure out the truth values for not B? They're just going to be what? The opposite. Yeah, they're going to be the opposite. That's the point of negation, right, is that we get the opposite truth value. So on the first row, B was true, so not B would be false. B was false, so not B would be true. Third row, B was true, not B would be false. And the last one, it was false, so it'll be true. That's it, we got that column. We're just flipping the truth value of B. Just the opposite. Okay. Oh yeah, one thing to mention, sometimes I see people try to do truth tables like all the way across. They try to go a row at a time and fill the whole row out. That gets really confusing. Okay? It's much easier if you do a column at a time. All right, so now we need to figure out the truth value of our whole compound statement. And I'm only going to look at 2 of these 3 rows when I'm doing it. I only need to look at A and not B. Okay? Those are the only 2 I had to focus on. So I'm just looking at this column, this column. And we're joining those 2 columns of truth values with OR. Okay? Now is when we need to know the rule for OR. And our rule for OR, there's different ways you can say it, okay, but the only time an OR statement will be false is if both of the simpler statements are false. Okay. So if we do the first row, we've got true, false. So one of those is true, so for OR that means it's true. Okay. In the second row, we've got true, true. So since we got trues in there, it's true. The third row is the one we're looking for. In the third row, we've got false, false. That's the only time our OR statement is going to be false. And then on the last row, false, true. So that one's true. Questions on doing that last column where we're getting those trues and falses from? Okay. That's it. And we got our truth table. And what it's doing for us is if we didn't have the actual statements here, we just had the symbols for them. But if we had the actual statements, we could follow the logic, okay, and say if we say statement A or not statement B, then depending on what our values were, we can figure out the truth value of our compound statement. That's what's going on. Okay. Let's see. Let's look at this other statement here. That's the same thing we just did. Yeah, here is a little summary slide. And I've got it worded a little bit there. I changed the wording a little, okay, with and or. So with and, I'm telling you it's true only when both P and Q are true, and the smaller statements. And then the way I have the or worded is it's true unless both P and Q are false. That's a little different than how the book has it. Okay. So one more statement here to look at. All right, here we've got a quote from John Wooden. He's a famous basketball coach. Okay, he played too from days of old. Okay. So the statement here is if you're not making mistakes, then you're not doing anything. Okay. We want to make a truth table for that. Okay. So the first thing to notice, okay, is that what kind of compound statement do we have here? We have if then. So this thing is a conditional statement or an implication. Right? That would be the one with the double-lined arrow. And then something else to pay attention to here is that our first statement has a not in there, and our second statement has a not in there. Okay? So they're both negated. So when we're doing the truth table, we're going to have our two starting columns, okay? But then we've got to make two negation columns because we've got to negate the first part in one and then negate the second part in the other. And then we can have our last column to do the conditional statement. Okay? So let's take a look at filling that out. So here, we're going to call you're making mistakes, statement A, and you're doing something, statement B. Okay, so symbolically, our compound statement would be if not B, then, if not A, then not B. Okay? That's the table we're trying to fill out here. Okay? So the first blank column we have is the not A column. Again, I'm just going to look at column A to figure out not A. So then I'm just doing the opposite truth phase. So it was true, so not A is going to be false. We had true, so not A is false. False turns into true. False turns into true. Just doing the opposite. The next column I need is the not B column, so I'm just going to look at column B. And then we're going to take the opposite of it. So true turns to false. False turns to true. True turns to false. False turns to true. And then for the last compound statement, okay, I'm only going to look at the not A column and the not B column, and then I'm going to use the rule for conditional statement or for implication. Okay. So let me get a different color here. Just looking at these two columns, and I'm using the rule for conditional statement. That's the weird one. Okay. Yeah, that's right. So what I do with conditionals, just so I don't end up getting confused, is I look for the special one first. Okay? Because I know a conditional statement's usually going to be true. There's only one time when a conditional statement is false, and that's if the first part is true and the second part is false. Okay? So if I look at those, I see that that happens on the third row. I'm going to go ahead and fill that in. It can happen more than once. You have to look at your combinations, but that's the only true false situation we have. And on the other ones, they're going to be true, okay? Because if we start with a false assumption, then our statement's true. And then on that last one, if both parts are true, that means we kept our promise. So here's our truth table. Okay. All right, so just for fun, thinking about the quote, okay, it was, if you're not making mistakes, you're not doing anything. So the only time that one would be false is what? So our first part was if you're not making mistakes. So if that's false, what does that mean? A little tricky to wrap your head around. That's why we use the truth table. So you're not making mistakes. If that's false, what does that mean? It means we are making mistakes. And we're also doing something. How's the second part? Then that's the only time his quote false. That part's not a big deal. Okay, being able to walk through all that. That is the basis of evaluating a logical argument, though. Okay. All right. We do have one special situation I think we're going to look at, and then we'll be done. Okay. So our special situation is if we go through and we make a truth table, and at the end, we find out that our compound statement is always true. So if it's true in every circumstance, no matter what kind of combination of true false we have, with the other columns, that is what we call a tautology. Okay. That's just when we have a statement that's always true. You remember last time we tried to come up with some statements that were always true and some that were always false. And the situation where it's always true is a tautology. So if you're in an argument with somebody, sometimes you will run across people using tautologies to make arguments. And the idea is a tautology doesn't not real useful trying to make an argument because no matter what you say, it's true. Okay? So not a very useful argument when you end up with a tautology. Okay? But let's look at one. And we'll fill out the truth table and then we'll be done. So I'm not sure on this name. Okay, I think this is the only place I've ever seen this name is in this example. And I see a lot of names, I have a lot of students come. Our compound statement here says next year Emory can take physics or he cannot take physics. You might be able to see right away that that's always has to be true, okay, because we've got two opposite possibilities. We're joining that with or. Okay. If you can't tell that, though, we're about to do the truth table. Okay. But take a look. If we call this part Emory can take physics, if we call that statement A, then what would the next part be? There's only a little bit of a difference with that second part from the first part. What is it? First part says they can take physics. Second part says cannot. So, yeah, so what's the difference there? This is the negation of that first part. Okay. So symbolically, the second part would be not A. And then we're joining that together with or. And so our compound statement would be A or not A. Okay. So that makes the truth table short because we only have one variable statement there. And we just have A that we're starting with. They're calling it C in the book. Okay. Same thing. So it makes our truth table smaller because when we're tracking the possibilities of truth values for statement C or statement A, whatever you want to call it, okay, we've only got two choices. It's either true or it's false. So then when we find not C, we just do the opposite, right? True turns to false, false turns to true. And then let's think about the last column. If we're making a compound statement with or, making a disjunction, the only time that compound statement's going to be false is if both statements are false. We can't have that here because they're opposites. We've got a true there, so this one's true. We've got a true there, so this one's true. So no matter what the situation is, whether Emory can take physics or he cannot take physics next year, our compound statement is true. Okay, so because of this, because our truth table is all true values, this is a tautology. So on the assignment, you'll have a few truth tables to fill out. And at the bottom, it'll say, is this a tautology? And if your compound statement's always true, yes, it is. If you have any falses in there, no, it's not. Questions? Ready for the weekend? Yeah. I was really happy when I woke up and realized today was Friday. That was nice. So. Okay. All right, have a good weekend. I'll see you next week. If you didn't sign the sign-in sheet, it's here somewhere. We'll find it and